In this demonstration, we will see how to configure microsegmentation in ACI directly from vCenter. We will be using the vCenter plugin for this purpose. We will start in stage 1 with 3 virtual machines that will be in a port group that has been created by mapping an EPG called ACI app to the vCenter VMM domain. We will also have an EPG pre-created where we will have bare metal databases. And in addition, we will have an EPG with a virtual machine that we will be using for provisioning purposes. This is not part of the demo and is actually part of another VMM domain. We will have pre-created contracts that enable access from our Ansible server to our virtual machines, and we will have also a contract that enables these virtual machines to access external repositories by connecting to a squid proxy on a specific IP address and port. Essentially, the virtual machines that are non-provisioned, web server 01, 02, and Tomcat server, will all be part of the same port group but still will be sandboxed. They will be able to connect to the proxy, and they will not be able to connect to the database, and they will not be able to connect to one another because they will be in an isolated EPG. All they have access to is the DHCP server to get an IP address and the required protocols and ports for provisioning purposes. Once the VMs have provisioned, they will have the right setting for them to be in the right environment once thereafter. In this demo, we will be using custom attributes for this purpose. So web server virtual machines will have a custom attribute that indicates they're part of web. Tomcat servers will indicate that they're part of app. Once the virtual machines have provisioned, we will use the vCenter plugin for creating new micro-EPGs. We will create 2 micro-EPGs, one for web and one for app. At the moment we create these virtual machines, there will be no connectivity between the web servers and the Tomcat servers or the database. We will need to add new contracts for that, and we will see how to do this. We will add a contract that will enable external access to the web servers, another contract that will enable the web servers to access the Tomcat server, and another contract that will enable the Tomcat server to access the database. This will be tested by an external desktop that will be generating connections to the web servers, as well as by running iPerf between the Tomcat server and the database. We will see how simple it is to connect a virtual machine to a bare metal database. In this case, both of them are in the same subnet. But there could be in different subnets as well. It doesn't really matter, there is no need for gateways. Then we will augment the contract to provide a next generation firewall for filtering the traffic that goes towards the web servers. We will do this by adding a service graph to the contract that provides access to the internet, and we will also add another service graph that adds an additional load balancer behind the firewall. Let's move to the demo. So this is the application ACI app on the test tenant seen from the visibility or from the view of the Fabric administrator. But for this demo, we're going to be using the vCenter plugin. We're going to be working with virtual machines that are all connected to the same port group. That port group is this one, test tenant ACI app. So we can see here our virtual machines, web server 01, web server 02, and Tomcat server 01. They're all on the same port group, they're all on the same subnet. The database that is running bare metal is also on the same subnet. Now we can look at the configuration by using the vCenter plugin. On the vCenter plugin, we're going to be looking first at the configuration of our tenant from a networking point of view. We have a single VRF, test tenant VRF, that has multiple segments or bridge domains. These are effectively implemented as VXLANs in the Fabric. We have segments for our firewall connections, external and internal, another segment for our load balancer connections, and then we have our test bridge domain with a subnet 10.10.10.1/24. This is the one we will be using for our virtual machines and databases. And then we have external connectivity. External connectivity is provided by 2 external EPG, one called Internet Proxy, that allows access to a single IP address, 507.249/32, and then an external EPG called Internet Access that provide access to any other IP address. Now we can look at the application profile as it is right now. In this application profile, we have our 3 virtual machines connected to the same ACI app port group and EPG. So this is equivalent to the one that we were looking at before. ACI app is both the name of an EPG and a DB port group. And this is where we have the 3 virtual machines. The Ansible server is in a different subnet, and as we can see, the icon is different. The icon is different because this is not under the same VMM domain. This could be effectively a server running on bare metal, on another vCenter, or on an OpenStack domain. It doesn't matter. Similarly, the icon is different as well for the ACMI SQL DB. This is where we have our databases, and in this case, these are bare metal databases. They're part of this application profile, but these were configured by our Fabric administrator. We have our external EPG that provides access to the internet proxy, and then we have a contract that enables access to the squid port, ICMP, and DNS, as well as our Ansible contract that provides ICMP and SSH traffic. From an external device, however, like this one, here we are in an external desktop. This external desktop is connected on the WAN, and this external desktop we will be launching pings to those web server IP addresses, and those pings will be failing. Of course, there is no contract for those devices, for this desktop external to the Fabric to connect. However, if we were to connect to web server 01, we can see that it actually can ping the proxy. We can see that we can ping the proxy. So we have all that we need in order to make sure that we can provision our application. Let's imagine that our application has already been provisioned, and we're going to see how we can configure the new micro-EPGs. So we're going to create a micro-EPG for web. Simply drag and drop. We configure web, and we select the subnet on which this micro-EPG is going to live. This allows us to reclassify the IP addresses from subnet, but in this case, we're going to select the same one, 10.10.10.10.1. We're going to enable intra-EPG isolation because we don't want the endpoints of these that are inside this group to talk to one another. And we're going to select VMs for web. We're going to select them based on custom attribute. And we're going to select an existing custom attribute. For instance, in the web server VMs, we can see that the custom attribute ACMI app tier is already configured. As we can see, we have now a new web EPG. It's a micro EPG, and we can see that the virtual machines web server 01 and web server 02 have been reclassified to that micro EPG. We can create another one for our application. I'm going to simply call it app. Again, we're going to select the network. We're going to also enable micro-segmentation and intra-EPG isolation. Select a VM. And again, we're going to select based on the custom attributes. And once again, we will see that the server 01, Tomcat server 01, has been reclassified to this micro-EPG. Any new virtual machine that I provision with a custom attribute equal to app or web will be classified to the corresponding EPG. Now, we probably still want these virtual machines to have access to the proxy. So what we can do immediately is add those to the consumer. So we can edit that contract and say, I want the new EPGs to also consume this contract. Part of ACMI app, we can see web and app. This enables us to decide whether we want these new micro EPGs and the virtual machines that move to those micro EPGs to retain the privileges of previous ones or not. And we probably also want them to have access to the Ansible server. There we go. So now I can still connect to those virtual machines like I could before. and from them they can still also ping my proxy. But now the interesting thing is I want to create new contracts. So I want to enable, for instance, the web servers to be accessible from my external desktop. So let's do that. This is very simple. We're going to add another external network. We can select from the ones that our Fabric administrator has pre-configured for us, one that enables internet access. So here it is, internet access, and now I'm going to create a contract that enables me to access the web virtual machines. I'm going to create this contract, call it web access, and I'm going to add the filters that I want to allow for external users to access those virtual machines. So I can imagine that I want HTTP traffic, maybe I want SSH traffic as well, and for my demo I definitely want to allow ICMP traffic. As soon as we've done that, you can see that our external desktop now has access to those virtual machines. Effectively, we are now allowing external devices that are coming through the L3 out to access these virtual machines on these ports and protocols. So now we need to add additional contracts for our application to be completed, right? We want to enable web to have access to app and app to have access to our database. So let's begin with the easy path. Let's create a contract between web and app. Let's call it Tomcat access. And let's initiate a ping between the web server and the Tomcat server, which at the moment is not working, of course. Let's add Tomcat traffic filter, and let's also add ICMP filter so that our test will work. And then again, we have enabled connectivity between these virtual machines. Fantastic. Now the interesting part. We want to enable connectivity to the bare metal databases. Again, this is one of the advantages of ACI because you can do it in exactly the same way. We will just say that we will just drag and drop a contract. We will just drag and drop a contract to the application, micro EPG. We will just drag and drop a contract to the micro EPG for application and select to connect to the ACMI database. Let's call it DB access. And once again, we're going to add multiple ports. We're going to add SQL, of course, that's our database. We want to add iPerf because we're going to be using iPerf to connect to the database just for our test, and ICMP. So once again, let's use our Ansible server here to connect to that server, Tomcat server. And from here, I'm going to ping the database. The ping starts working. And you can see how simply it is to add connectivity to this database. .10.10.10.114. Now, this is a server connected into a VXLAN, and this is a server connected in a VLAN. Again, there's no problem for that. They're all on the same subnet, and there's no performance penalties. And we're going to look at that. Let's look at this in the Fabric. So here we can see our app. It's our Ansible server, it's our Tomcat server 01, 10.10.10, 106, connected on a VXLAN, on a micro EPG, and we have our database. 10.10.10.114, connected on a VLAN. So now we're gonna start an hyper server on that. Just listening on port 5201, and we're gonna initiate a simple hyper-3 connection to that server. So we can see 9.83, 9.85, close to 10 gig, without any performance tuning, without any problems between bare metal and a virtual machine. So this concludes the demo, where we can see that from vCenter you can actually provide secure connectivity between web, access and DB, virtual and physical endpoints. Now what happens if we want to add a firewall to this connection? Let's say the traffic that comes from external, traffic that is coming from this host, we want it to pass through a firewall. So this host is having the IP address 192.168.203.200.3. Here we have a firewall that is at the moment not configured. It only has configured the management IP address, but this firewall is registered to be managed by a service graph from APIC. So let's add a service graph directly from vCenter to insert that firewall. What we're going to do here is simply select to configure an L47 device. And now we're going to select between the internet access and the web which device I'm going to configure. These devices have been pre-configured by the fabric administrator or the security administrator, or both. We can select from the common tenant as well as from the user tenant. In this case, in my test tenant, I have a selection from a number of service graph templates. I'm going to choose the first one, Cisco ASA. Now here, the configuration is incomplete. This may be completed by the fabric administrator or security administrator beforehand, but in this case, I still have to add. So I have multiple access lists that have been pre-configured. And all I have to do is simply write the test tenant acme app web EPG that I'm going to be connecting to. Now this is only because I actually want to avoid configuring any IP addresses, and I want to simplify configurations as much as possible, while leaving the administrator of the vCenter in this case to have the possibility of reusing this firewall for multiple purposes. So there we go, that's it. Now I have to select the bridge domain. Remember that we have bridge domains dedicated to our external and internal firewall connectivity. Here I'm going to select the outside and the redirect policy from L3 out to firewall. This is going to be my external interface on the firewall. Similarly here, I have to select the internal of the firewall. Firewall inside. And the redirect policy. This is going to be from web to firewall. And this is going to be my internal interface 1. Now, once this configuration has been done, a few things will happen. The APIC will begin to configure the firewall. We can see already connections to the firewall where we're actually configuring interfaces, bringing them up. And we can see the interfaces have been configured with the right IP addresses on the subnets that we configure for external and internal connectivity. The interfaces are up now. And we can actually look further into the firewall configuration, and we can see that the access control lists that were defined by our security experts that allow access to HTTP, HTTPS, and ICMP have been configured. They have been configured with an object that matches the EPG that I added on the configuration on the wizard that I did on the vCenter plugin. And this is what enables the firewall to automatically know the IP addresses that it needs to filter for. These are the IP addresses that exist on my web micro EPG. While this configuration is shown here with a Cisco firewall, similar configurations can be achieved with other vendors. Now the pings continue working, but these pings now can be observed on the firewall logs. So now we have added the firewall to the filtering between the external users and our web users. Thank you for watching.